Now that you've completed the activities, you should know that dilations either make something big or make something small. And that's called a reduction. And we're going to show dilations both in a coordinate plane and then with just coordinates. So we're going to show it both ways, just like rotations, just like reflections. And then you'll see how we dilate things to make them bigger or smaller in those two different methods. So you should have gotten this handout along with the packet for dilations. And what we're going to do is we're going to first work in here with these two. Okay, and then these three problems are going to be on your own problems that will go on the left. So we actually have quite a bit to fit in the notebook for this entry. You're going to want two different colors. I'm going to use red and blue. The reason we're using two different colors is because I want you to be able to look at your notes and see that enlargements in one color and reductions in one color, so you can see the difference about how the coordinates change and what that scale factor is that we'll talk about soon. What I'm going to have you do is cut out the large coordinate plane and these two boxes, and I'll show you how that's going to fit in your interactive notebook. So this is what our entry looks like right now. You can see that we kind of have to cram a lot of words in here, but dilations are, by definition, a transformation that changes the size of a figure by a scale factor called k. So that scale factor is just what we're multiplying all these points by. It's either going to get bigger or going to get smaller based on the scale factor. And we have two examples we're going to do. The first one is we're going to dilate triangle ABC by a scale factor of 1/2 with respect to the origin. In the next one, we're going to dilate triangle ABC by a scale factor of 2 with respect to the origin, and we're going to see how that changes the points. Right now, we can fill in for the points A, B, and C on each of these charts. A is going to be at 2, 1, B is at 2, 5, and C is at 5, 1. So you can pause the video and do that now. And now that you have those coordinates in there, let's take a look at how this triangle ABC changes based on the scale factor. So before, in the previous entries, what we would do is we would rotate or reflect the object in the coordinate plane, and I would ask you to find a pattern for the coordinates. We're going to do the opposite this time. Okay, we're going to work with the coordinates, and I'm going to have you find a pattern for the figure in the coordinate plane. So we're kind of going the other way around, but you're still recognizing patterns like mathematicians do. Dilate triangle ABC by a scale factor of 1/2 with respect to the origin. So this is our first problem. Now when we dilate something by a scale factor called k, what we have to do is multiply every single coordinate, okay, both x and y, by whatever the scale factor is. So in this case the scale factor is 1/2. Sometimes it's helpful to put k equals 1/2. You could put k equals 0.5 if you wanted to. And now what we're going to do is, I'm doing this problem in blue so you can see the difference between the problems. We're going to multiply each of these values by 1/2. So 2 times 1/2 is 1. And 1 times 1/2 is 0.5. Same thing over here. 2 times 1/2 is 1. 5 times 1/2 is 2.5. 2.5. And finally 0.5. And now we're going to plot those points, and we're going to see how the triangle looks. So again, I'm using blue. A went from 2, 1 to 1 and 0.5. So A went right here. There's A prime. B is now at 1 and 2.5. So that's 1 and 2.5. That's B prime. And C went from 5, 1 to 2.5, 0.5. So there's C prime. And so there's my triangle right there. You can do your best to connect the triangles and we'll shade them in. And that's how you dilate by a scale factor of 1/2. So sometimes it's okay. You can estimate where half is on your coordinate plane. What's important though is when you're asked what the coordinates are after a dilation, that you show this. Okay, this can be kind of an estimation, but they're going to want to see you're accurate with the coordinates. And next up is example 2. So number 2 is dilate triangle ABC by a scale factor of 2 with respect to the origin. So you can see from both examples, we're always dilating with respect to the origin. If we were to dilate with respect to another point, what we would have to do is we would have to actually translate the whole triangle so that it would line up with the origin. Then we can use this rule of multiplying every number by the scale factor, and they would have to translate it back, so it'd be kind of confusing. So in general, when we dilate things, it's always with respect to the origin. When you think about dilating in general, like dilating your eyes when light is shined in them, usually things dilate from their center. And when that happens, you'd expect the triangle to get bigger around itself. But that's not the case when we dilate with respect to the origin instead of with respect to the center of an object. So I'm going to do this problem in red to show that it's different from problem 1. And we are dilating by a scale factor of 2. So I'm multiplying every one of these values by 2. 2 times 2 is 4. 1 times 2 is 2. 4, 10, 10, 2. And then I'm going to plot those points on my coordinate plane. So we've got 4, 2, that's 1, 2, 3, 4, 1, 2. Practically right on the triangle. And this is A double prime. And then we've got B at 4, 10. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right at the top. And that's B double prime. And finally C is at 10, 2. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then up 2. There's C double prime. And we can use a ruler to connect that triangle together. And to make it easier to see, we're going to shade that in as well. Okay, so we've got 2 different scale factors, 2 different dilations of the same exact figure. Now, when we talk about dilations, there are 2 different things that can happen. Either an object gets bigger, called an enlargement, or an object gets smaller, which is called a reduction. So, let's take a look at what happened in these 2 problems. When I multiplied this by 2, it got bigger. When I multiplied by 1/2, it got smaller. If you were to multiply everything by 1, it would stay the same. So when we talk about dilations, we talk about scale factors, there's a specific statement that we can say about whether something is a reduction or an enlargement. If you move down in your notebook, we're going to have some more notes to write in. You can see a dilation creates similar figures. Similar figures are proportional figures. They have the same shape, the same angle measures, but they're different sizes. So if we take a look at our triangle here, or triangles, you can see that they all have a 90-degree angle. They're all right angles. And angle B, angle B, angle B, those are all the same measures. You could actually take out a protractor and measure it if you wanted to, but we know that they're proportional. And another thing that I wanted to mention when we talk about dilating things with respect to the origin, take a look at what happens if I put a line through the origin. Let's say I wanted to connect all the points for B. That line went through B, B, and B, and the origin. Same thing would be true for A. If I put a line through the A's, that would also go through the origin. Same thing for C. A line through C's, also through the origin. So that that with respect to origin, everything is kind of starting from here and either going out or coming in. Kind of think of it like the singularity of a black hole. Kind of things, you know, either pull towards it and reduce it, or they blow it away and it gets enlarged. That's how I think of it. Moving back down to our notes, we can see that example 1, we had a scale factor that was less than 1, and that gave us a reduction. So any scale factor that's less than 1 is going to reduce the figure, because anything less than 1 is not a whole. Anything greater than 1 makes something bigger than one whole, bigger than the one whole triangle, and that's an enlargement. So those are the two different types of dilations that you'll run through. Now on the left side of this entry, you're going to cut out those smaller coordinate planes, and those are going to be your practice problems. So the first one is you're going to dilate triangle JKL by a scale factor of 2 with respect to the origin. And I want you to show the table of how the coordinates change. The next one, you're going to dilate triangle ABC by a scale factor of 1/2. And the last one, you're going to state what the scale factor is from triangle QRS to triangle Q prime, R prime, S prime. So what is that scale factor? What do we multiply all those coordinates by to get to the new figure? After that, you'll have your teacher check all 3 problems, and then you can move on to the practice problems at the end of the entry.